In this portion of Chapter 3, I present results associated with standard error of the means estimated through resampling, as well as standard error of the means estimated through the formula approach. And in the first table, I have the means in a row, and each column heading is the sample size, 5 all the way to 5,000. And we can see that the standard deviation for that first sample mean with 5 cases was estimated at 1.673. And when that's inputted into the standard error of the mean formula, which is standard deviation divided by the square root of n, I got a formula-based estimate of the standard error of the mean equal to 0.75. And that's why I put 0.75 over here. Now, the standard error of the mean estimated through resampling was estimated at 0.51 across the 10 samples that I estimated. So they're similar, but not exactly the same, and you wouldn't expect them to be. But as I get into larger and larger sample sizes, the standard error estimated through resampling and the standard error estimated through the formula approach begin to converge on each other because of the power associated with increasingly large sample sizes to estimate accurate standard errors of the mean. So to recapitulate, resampling and formula-based approaches are basically two different approaches to the estimation of the same phenomenon, which is standard error of the mean. And I hope that by demonstrating the resampling approach to the standard error of the mean, which involves calculating an actual standard deviation on sample mean estimates across, say, 10 samples, that you get an understanding that the standard error of the mean formula approach is doing essentially the same thing, but in a very clever way, because mathematical statisticians discovered that the standard error of the mean can be estimated with a formula rather than having to use some kind of resampling approach.